Hi, greetings to you all. I am Singhuchuan. I am going to explain the interesting concept in class 11 and 12 as well. Actually, that is calculus. It started from class 11 itself. Okay, the concept is calculus. Okay, the calculus is actually two important branches, that is differentiation and integration. The differentiation and integration, to understand differentiation and integration, there is a very important concept, the minor and the fundamental concept is called limit. Let me have a small introduction about the limit, and then we will go to see what is differentiation and integration. So what is this limit? To explain this concept, let us have a small example. The function f of x is splitted function, f of x equals to x square, where x is not equals to, and it can be 1 for x equals to 2. It means for x equals to, the value is 1, for x is not equal to, the function is x square. Try to draw this, represent this in your graphical way. So draw a xy plane and consider, hopefully we know that this is a parabola open upwards. So for x 1, 2, here left side minus 1 and minus 2, similarly 1, 2, 3 and 4 and so on. We are not going to draw all the things, I am just going to give an idea of limit. So let us consider for x equals to, first of all x equals to, it is actually 1, x equals to actually it is 1. How about x is not equals to? That means x is not equal to means the left side value, all the left side value is considered and all the right side value is considered. So what are the left side values? Means the 1.99, 1.999, the values which is very closer to 2 can be considered. And similarly the right side values are 2.0001, 2.0001 and 2.1 as well as that. So likewise, when you are giving the values in the place of x that are from the left side of 2 and the right side of 2, we won't, since we cannot give the exact value of 2, but we can able to get the idea where it reaching. So that is called limit. So you can see that obviously all these values are approaching towards 4, and we know that exactly at equals to, we can't represent the value there in this function. So we can't give x equals to 2, so that we are just noting it as with your open circle, the empty circle, and furtherly we can increase the graph even in the left side. Left side there is no problem because all the left side values are acceptable. So this is a graphical representation of the function. So what is the idea are we getting and why are we calling it as limit? So that concept is called the limit. What is the concept is called? We are able to, still we can't find the exact value of 2 for the function, but we can give the approximate value of the function which tends to 2. That is where the limit is exist. So limits, shortly writing it as LIM, x tends to 2 not equals to for the function f of x which is equals to 4. Okay, I am just giving a very simple and very short form of explanation for this, because our major explanation is in a differentiation. So this is the concept of limit. It is approximate values of 4. So though we are not able to give the exact value of x in the function, but we can find where this function is approaching where the left side value and right side value of 2. So that is the concept of limit. It is very important, and as well as it is majorly, without understanding this concept of limit, we cannot understand the concept of differentiation as well as integration. Okay, now let me explain the concept of differentiation. What is differentiation? Actually the differentiation is majorly used in many field, we know that actually. So now what is the idea of this differentiation? Where this idea is came from and how this concept is raised actually. When the question is raised, what is the instantaneous rate of change? And that means instant rate of change of the function. Change of function at particular point, let's say P. So this is actually where we are talking about the concept of differentiation. This is actually called a derivative of the function. Okay, so to find this instantaneous rate of change of the function, there are many other concepts you should know for sure. Okay, there are like the steepness, slope of the secant, slope of the tangent, and the slope of the 2 point. Actually, all these formulas are going to use here. These are all basics and fundamentals. Hope you know all that. Okay, so to find the instantaneous rate of change of the function at P, which is actually equal to slope of a tangent of a curve at P. So this is the idea. Okay, why are we having a curve? Because for example, if you are taking your graph for a distance time graph, clear, usually in initial class we will have a straight line, but actually it is not actually straight line, we may have the curved line. Okay, there will be a increase in velocity, decrease in velocity based on the situation. Okay, now so to find what is the speed of the vehicle at this point, to find what is the speed of the vehicle at this point, it is not easy to find without knowing the concept of differentiation. Okay, once you know the differentiation, we can easily find the particular the speed of the car at the particular point. Okay, let's see how can we find it. So that is what I said, the slope of the tangent of the curve. What is what is the tangent of the curve, right? Tangent of the curve is the tangent can be drawn through only one point of your curve. So I am going to draw your tangent. If I am able to find the slope of this tangent, that is equals slope of this tangent through that point P, then that is equals to instantaneous rate of change of a point, instantaneous rate of change of the function at particular point. So how can you find this? That is the question, that is the big question. For that only we need to know the slope of the secant. So we are deriving it from the slope of the secant, because to find the slope obviously we need a 2 point. So I am just going to draw the another graph in the same format. I am taking a point P at some place here, and I need another point Q on the graph. Okay, clear? That is at particular distance. If this is x at particular distance, the distance of del x, I am going to take it as this point. So this is obviously going to be x plus del x. So what is the function of this? So this will be f of x, and this will be f of x plus del x. When it comes to the point, what is the point of P? P will be x comma f of x, and Q will be x plus del x comma f of x plus del x. So now if you draw the line through these 2 points, this line PQ is called a secant. Now you can find the slope of the secant. How? By using the 2-point formula. 2-point formula is y2 minus y1 divided by x2 minus y1. When you are applying these values in the formula, you will get f of x plus del x minus f of x and divided by x plus del x minus x, then xx will be cancelled, then you will get only del x. So now our idea is to find the slope of the tangent. So now what we have to do is we have to convert the secant line into the tangent line, so that when it can be happen, that means these 2 points, that means the point Q must go nearer to the point P, then only we will get your tangent, the idea of tangent. Okay, so for that I have to decrease the distance, that del x to 0. So there the concept of limit is exists, and you will get the tangent slope of the tangent. So when you are reducing or approaching the value of del x tends to 0, this point will come closer to closer, and you will get only the slope of only the tangent, and you can able to find the slope of the tangent. So what is slope of the tangent here is limit del x tends to 0 f of x plus del x minus f of x divided by del x. So we've arrived to the conclusion that is slope of the tangent at a point P is limit del x tends to 0 f of x plus del x minus f of x by del x. This is actually the slope of the tangent of the curve at point P, and this is your instantaneous rate of change of a function at point P, and this is called a derivative of the function, and this is known as differentiation. So there we use the two formulas actually, that is the slope of the secant, that is y2 minus y1 by x2 minus y1. The concept of slope is it's another part we have learned in our earlier classes also. So from here we can find the what is we can understand what is actually the differentiation. Differentiation means to find the instant rate of change at particular point of the function in a motion actually, so that if you want to find the instantaneous rate of change of at a particular point, we need a 2 point. From with the help of the 2 point concept, we can convert the slope of secant into slope of tangent by using the limit. That limit, when you are applying a limit of the function slope of the tangent of slope of secant, we are getting a slope of tangent, that is called a differentiation. Now actually we can use this concept to find the derivative of sin x. How do you find the derivative of sin x? Derivative of sin x, that is we can say that f of x is equals to sin x. Now I am going to find the derivative of sin x. This is can be known as d by dx of sin x. Okay, this is also known as d by dx of sin x. So therefore that is d by dx of f of x is equals to limit x tends to 0 f of x plus del x minus f of x by del x. Now quickly solve this sum. The f of x equals to sin x, so I am going to find the derivative of sin x. So using the formula, so what is the d by dx equals to sin x means f of x equals sin x, then the formula is limit, actually here del x tends to 0, right? Instead of del x I am going to use h tends to 0 and f of x plus h minus f of x divided by h. So apply this value in place of x, so that you will get limit h tends to 0 f of x plus h is sin of x plus h minus sin x divided by h. Limit h tends to 0, sin of x plus h is actually sin a plus b. Sin of a plus b is sin a cos b plus cos a sin b minus sin x whole divided by h. Now we have a sin x common, you just take it out, sin x common, when you are taking sin x common, limit h tends to 0 on sin x, when you are taking sin x as common you will get, actually take minus sin x as common, so that you will get 1 minus cos h plus cos x sin h, and now you just give h into in a dividend form, you can distribute h into the two functions. From later we have a function with the variable h only, then the sin x can be considered as your constant, you take it out, minus sin x as out as a constant, you just take it out, then limit x tends to 0, we know the formula 1 minus cos x equals to 2 sin square h by 2 by h, and plus again you can give the limits to the other function also separately. So limit before that take cos x outside, then you will have limit sin h by h, h tends to 0. So here limit h tends to 0, sin h by h is equals to 1, then you will have only cos x. Here minus sin x, 2 sin square h by 2, you just brought this 2 into denominator, then you will have a limit h tends to 0, sin h by 2 by h by 2, and one more concept into limit h tends to 0, sin h by 2 plus cos x into 1. So again this will be h tends to 0 is if h tends to 0, h by 2 is also tends to 0, so that this is going to be equals to 1 and this is going to be equal to 0 because sin 0 is 0. So minus sin x into 0 plus cos x, which is equals to cos x. Therefore derivative of sin x is equals to cos x, hence found. Thank you.